Hello folks, in this video I'm going to go over the procedures and formula for constructing a confidence interval for means. So I'm not going to go over in a great amount of detail the whole procedure because it's basically the same as what we did for proportions. We're still using that acronym PANIC, panic, to make sure that we capture and hit all of the parts that we need to hit. But what I really want to focus on at the start of this video, especially before I do some examples for you, are the differences from what you did with proportions. Okay, so a confidence interval is still giving us a range of plausible values for the true value, the parameter, which in these problems is going to be a population mean. Okay, you still create it using a point estimate. So in this case, that would be like your sample mean, right? Plus or minus a margin of error, okay, where your margin of error is the standard error, right? So standard deviation, but for a sample, times the critical value, right? Which makes your interval wide enough to have your stated capture rate, right? And your stated confidence level, okay? The structure, the conditions, and all of the interpretations and the scripts that you learned in the last unit for proportions stay the same, okay? There are a couple of key differences here, okay? So the first key difference is that the success-fail condition, you don't have to do the NP and the N1 minus P because we're dealing with means, not proportions. So for your success-fail condition, you're just checking to see if the sample size is greater than or equal to 30, or if you have a normal population. Okay, if this condition is not met, which we kind of talked about in the last video when we went over how to know if you can use the T distribution, the T star values. Okay, so if the success-fail condition is not met, right, you don't have to just stop the problem automatically, right? Do a quick sketch of the data that they give you to assess normality, right? So meaning you're looking for like any very obvious clear outliers or an extreme skew. If you don't find either of those, even if the sample size is smaller than 30, you can still continue with the problem. Okay, so that's the first big difference. Okay, the second difference is that you're going to use a T star value. So T star is your critical value from the T table, instead of using a Z star value from the Z table. Okay, so if you recall, right, one of the things that you have to do when you construct a confidence interval at that end step is to name the interval, okay, and one of the questions that you want to ask yourself is always, are we using Z or T? I told you in the last unit for proportions, you're going to use Z. Z goes with proportions. Well, now we're working with means. T goes with means, okay? So that's the second big difference, okay? And the third difference is that the standard error formula changes. So you don't have the square root P times 1 minus P over N, okay? You have your sample standard error divided by the square root of N, which is the sample size. Okay, so the full interval, right, with labels looks like this. Okay, so it's X bar, so that's your statistic, plus or minus T star is your critical value, times SX over the square root of N. Okay, so if we're going to label these things, okay, okay, X bar is your sample mean. Okay. T star is your critical value. Okay, and then inside the parentheses there is the standard error of the sample mean. Okay. When you go through and do these problems, right, you're still using the exact same panic procedure. Okay. Oops, sorry. I went a little too far there on the left. Okay, so remember P stands for parameter, where you state the parameter that you're trying to estimate. A stands for assumption, so you check those three conditions, randomness, 10%, and success fail, / large counts. Right? N is name the interval. I stands for, that's like your math step, so calculate your your new standard deviation, find your critical value, etc. Okay, and then write your interval in plus minus form and interval form. And then C stands for your conclusion and context. So that's where you do your interpretations. All right. So I am actually going to do not this first example, because I'm going to have you all try that one on your own. But I'm actually going to do this second example that's on page 7 of your notes, because it has some data. So I want to talk to you a little bit about how to how to enter that in your calculator. So I'm going to do this one that starts on page 7, where we're talking about tension in TV screens. So give me a second to kind of rearrange my screen a little bit, and then we will do this problem together. All right, y'all. So if you are given a problem where they don't give you summary statistics, but rather they give you the actual data, which honestly doesn't occur very often in like the first 5 free response questions, but I've seen it show up a couple of times in different investigative tasks. So it's worth knowing how to quickly enter data into your calculator, your TI Inspire, and then be able to run one variable statistics on it in order to get your sample mean and your sample standard deviation, your sample size, all of that fun stuff. Okay, so if you are given a data table instead of summary statistics, these are the commands, and this is how you enter data into your calculator in order to get the sample mean and the standard error from the sample, which you need in order to construct your interval. Okay, so on your calculator, you would add a list and spreadsheet document and then just enter your data into one column. I would advise that you name the column at the top, just so that, like in the very top row, just so that it makes it a little easier for you to find the data that you're looking for later. Okay, so go ahead and enter your data. You can check normality if the sample size is less than 30, using this thing called a quick graph. So you would just go into the data list, click menu, and select data, and then click quick graph, and it'll make a really fast dot plot for you, just so you can kind of see what the data looks like. You can also just sketch the data for yourself, like by hand, if you want to do that. Okay, so that kind of goes with your assumption step, right? Because that goes with the success fail / large counts. Okay, now in order to do the actual math, you have to know the sample mean and the sample standard error. Okay, so the way that you calculate that, or the way you have your calculator do it for you, is using one variable statistics. So you would click statistics, or click the menu button, right? Then select statistics, stat calculations, and then you're running one variable statistics, right? And then you would just select your column that you entered all of the data in. If you named the column at the start, then you can just select the name of the column and it'll run the information, or it'll run the statistics for you. Okay, when you run one variable statistics, you're going to see mu and the standard deviation. So you're going to see both of those, both of those parameter values. That's not what you want to read, okay? Because your data set is not going to be a population, it's a sample. So you always, always, always want to make sure that you read X bar and SX, right? So things are going to show up for you like in a list. It'll have like mu something, and then it'll have like what it is here, and then it'll have like X bar, and it'll have what X bar is, it'll have this, and then it'll have like SX, right? When you actually run the one variable stats. So you want this and this, okay? Because otherwise your numbers are going to be a little bit off, all right? So let's go ahead and actually try this, okay, with one of these problems. So in this problem, I'm dealing with tension in TV screens. They did a random sample of 20 screens from a single day's production, and they want us to construct and interpret a 90% confidence interval for the mean tension of all screens produced on this day. And they gave us just this, right? This is all that they gave us, is this data set. So I went ahead and I plugged that information into my calculator and ran one variable statistics on it, and I got this mean and this standard error. So I'm going to need that to complete this problem, okay? So once I have that, I can kind of go through my steps here, okay? So I'm actually going to leave this up, move this over just a little bit, zoom in a smidge here, and go through the procedure here for my confidence interval. Okay, so first up is my parameter, right? So what are we estimating? So we're estimating the true mean tension of all TV screens made this day, right, on this particular day. Okay. A is assumption, so randomness. Is this a random sample? And yes, it is. They told me it was a random sample. So you can just say SRS, stated in problem. Okay. Okay, next is the population 10 times or larger than 10 times a sample. So remember, you do 10 times the sample size. Sample size is 20. Okay, and that's, so 200 is definitely less than the total number of TVs made that day. Okay, that's reasonable, all right? Okay, last is my success fail / large counts. So here, my sample size is 20, which is less than 30, and I don't know the shape of the population. So I have to check and see what my data distribution looks like. So I'm just going to sketch this out really quickly. This is a very, very rough sketch. So I'm kind of starting down here at like 230, and then my largest value is like 380 something. So I'm going to go up here to like 390. So this is 270, 310, 350, right? Again, this is a very rough sketch, right? And I kind of did this beforehand, so this is like just a general, like kind of what this looks like. So as you can kind of see as I'm putting this together, that there's not going to be like any crazy like outliers or skew here. right, so there's a very rough sketch of my data, which you could get from your calculator, or you could do by hand, like I did this by hand, okay? So even though my sample size is less than 30, but the graph of the sample data shows no outliers or skew. Okay, and this right here is the graph of my sample data. Okay, so we're good. We've checked all our conditions, so we're good on conditions. Okay, N stands for name the intervals. So remember, there's a couple of questions that you ask yourself. The first is, how many samples are we dealing with? And there's only one. So this is a 1. Are we dealing with means or proportions? This is means. Okay, so a 1 mean and then Z or T. So this is T. And then obviously this is an interval. Okay, so a 1 mean T interval. You may sometimes see this called just a 1 sample T interval. Okay, technically both are correct, right? Okay, so for the actual math step, we have a couple of things that we need to note. Okay, the first thing that we need to note for ourselves is X bar and SX, standard error. So these are the things that I got from my calculator. So X bar was 306.32, okay, and SX was 36.2093. Okay, now I know in order to find my T star, I need my degrees of freedom. Okay, so N is 20. So that means my degrees of freedom is 19, right? 20 minus 1, which is 19. Okay, so then I'm going to go to my T table. So they said we're dealing with a 90% confidence, and my degrees of freedom is 19. So here's a degrees of freedom of 19 right here, and I'm dealing with a 90% confidence. So my T star value is right here, 1.729. Okay, so T star, that's my critical value, is 1.729. Okay, and just a reminder, these two numbers, X bar and SX, come from the calculator. Okay. All right, so now that we're here, we have all the information we need in order to construct our interval. So remember, it's X bar plus or minus T star SX divided by the square root of N. Okay, so X bar is 306.32 plus or minus T star is 1.729 times SX is 36.2093 divided by the square root of, and N is 20. Okay. All right, so if I do in my calculator 36.2093 divided by the square root of 20 times 1.729, this is what I get. So I have 306.32 plus or minus 13.999. Okay, so this would be like my plus minus form. Okay, and then my interval form, I would actually add 13.999 and actually subtract 13.999 from 306.32, and that's going to give you my lower and my upper bound. So when I subtract those, I get 292.321. Okay, so that's my lower bound, and then when I add them, I get 320.320, and I'm rounding, obviously. a little bit. Okay, so this would be my interval form. Okay, and then my very last step here is my conclusion and context. So this is where you use your script. So you would say, we are 90% confident that the interval from 292.321 to 320.32 captures the true mean tension in TV screens produced this day. Right? You could have written your interval slightly differently. You could have just said, we are 90% confident that the interval, and then just state the interval as it's written here, and then you could continue on, right? Same idea. All right, y'all. So what I would love for you to do, now that you've seen an example, I want you all to try the one that we skipped, okay? But in this one, this is actually a little bit easier because I'm giving you the information that you need. So my sample size is 36, and I gave you X bar and SX. So you don't have to plug anything into a calculator. This is just the straight panic procedure, okay? So pause the video, give this a try, and then check back with me to see how you did. All right, y'all, so go ahead and check your answers against mine. So in this problem, we were trying to estimate the average weight of an Oreo cookie. Okay, so that's the parameter that we're examining. We're estimating the true mean weight of an Oreo cookie. Okay, my sample size here was a random sample of 36 cookies, and then they gave me the mean and the standard deviation, or technically standard error, from the sample that these two AP Stats students took. So for my random sample, yes, this is a random sample. It was stated in the problem. For the 10% condition, right, I want to check to see if the sample size is less than 10% of the population. So 10 times the sample size is 360, which is definitely less than the total number of possible Oreos that these students could have selected. Okay, and then I don't have to check any sample data or anything here because my sample size is 36, which is greater than 30. So I'm golden there on my last condition. Okay, for naming my interval, this is a one mean t interval, or you could have called it a one sample t interval. Okay, those two are kind of interchangeable. Okay. Okay, once we get to I, that's our actual math step. So they gave us the mean standard deviation of the sample, okay, which are listed there, X bar and SX, okay, and then I need to find my critical value, my T star. In order to do that, I have to know my degrees of freedom. So remember, sample size is 36, so degrees of freedom is one less than that, so 35. In the actual T table, you will have to round down because 35 is not on the T table as a degrees of freedom. So remember, if the number that you have for degrees of freedom is not on your T table, just round down to the next nearest number and then pull your T star from there, okay? So I had to round down to 30 because that was the next closest degrees of freedom below 35. So at 95% confidence with that particular degrees of freedom, I got that my T star value was 2.042. Right? So that's my critical value. So now I have X bar plus or minus T star times standard error divided by the square root of n. Okay, so that's 11.3921 plus or minus 2.042 times 0.0817, that's a standard error, divided by the square root of 36. So when you multiply all of that stuff together, the 2.042, the standard error, the square root of 36, you get 0.0278. So that's your plus minus form right there. Okay, and then I have to actually add and subtract 0.0278 from 11.3921 because that's going to give me my lower and upper bound of my interval. So subtracting gives me this value, my lower bound, 11.3643, and then adding gives me my upper bound. this number, 11.4199. Okay. All right, and then my very last step here is my conclusion and context. This is where you're going to pull out your script. We are 95% confident that the interval from 11.3643 grams to 11.4199 grams captures the true mean weight of an Oreo cookie. This is one that I did have units that I could actually actively work in, which you should do if they are given to you. In the first example that I did, they didn't really have a unit, like TV tension, like tension in screen doesn't really have a unit, but they didn't give one to me, but they did tell me in the problem that they were weighing these cookies in grams. So I did have a unit for this one, okay? All right, then that last question there says, on the packaging, the stated serving size is 3 cookies and 34 grams. So the question is, does the interval we constructed provide convincing evidence that the average weight of an Oreo cookie is less than advertised? Okay, so if it's 34 grams for 3 cookies is what's advertised, then that means I do 34 divided by 3, that's going to give me the number of grams for 1 Oreo cookie. So that's 11.33. If you look at our interval, 11.33 is not in the interval, and it's actually below the interval, right? So our interval actually suggests that the true weight of an Oreo cookie is actually more than 11.33 grams per cookie. All right. All right, y'all. So that is it for this confidence interval video. As always, please reach out to me if you have any questions. And I will see you in the next video. Bye, everybody.